This is r.d.sharma solution. We are taking class 12 chapter 19 exercise 19.32 indefinite integrals. So in this question there will be a different approach. First we need to get rid of the under root. If it is easier then we can do, because the linear equation inside a root can be easily converted, but this is a quadratic equation. So we'll do something with this x plus 1. We'll take this x plus 1 as 1 divided by t. So the t will become 1 divided by x plus 1. Let's differentiate both the sides. Left will be 1. We are differentiating with respect to x. So negative 1 by t square dt by dx will come. So from this we are getting dx. If you take dx on one side, the remaining content on the right hand side will be negative dt divided by t square. Now we have to convert this x square plus x plus 1 in terms of x. See, x plus 1 is already 1 by t. X will be 1 by t minus 1. X square will be 1 by t minus 1 whole square. So this integration will be like this. First thing, we got dx. We can write negative dt divided by t square. Then we have x plus 1. We can write it as 1 by t. Under root x square plus x plus 1. In place of x square, we can write 1 by t minus 1 whole square. And in place of x plus 1, we can write 1 by t. So what is the benefit? Let's square it. A minus b whole square we are applying. A square plus b square minus 2ab. And then we have 1 by t also. This will be 1 by t square. 1 by t minus 2 by t will be negative 1 by t. And this is 1. Now take the LCM, t square. This will be 1. This will be t. And this is going to be t square. And this is inside the root. So when you take it inside the root, the denominator t square will come out. So only one t will remain, and this t square minus t plus 1 remains like that. So this t square and t square will get cancelled. So the integration has become like this. Negative we are taking outside, dt divided by t square minus t plus 1. Let's make it as a perfect square. So the coefficient of t we take, divided by 2, square it, add it and subtract it. That is 1 divided by 2 whole square will be added, and this same will be deducted also. So a square plus b square minus 2ab. So t square plus half square minus t will become t minus half whole square. Then we have 1 minus 1 by 2 whole square, that is 1 minus 1 by 4. That gives you 3 by 4. In order to write it as a perfect square, you can take root 3. Denominator is 4, that is 2 square. So you can write it as root 3 by 2 whole square. So the denominator has become t minus half whole square added with root 3 by 2 whole square. There is a square also here. Now we have a formula. What is the formula? Negative remains like this. It will be log x. In this case, x is t minus half. So t minus 1 by 2 will be x. This will be the first thing. Then plus, and inside this root, whole this t minus half whole square plus root 3 by 2 whole square will come. And if you remember, this was nothing but t square minus t plus 1. So you can just write t square minus t plus 1. So as I suggested, we can just write t square minus t plus 1 in this place, because we have added half square, we have subtracted half square, and then we have arrived to this particular under root. So t square minus t plus 1 will replace t minus half whole square plus root 3 by 2 whole square. So let me write this. T square minus t plus 1, and this t minus half is also there. So we'll replace now t. So this final result will be something like this: minus log, inside the modulus sign, it will be t minus half plus under root. I told you that you can write it as t square minus t plus 1 plus a constant of integration. Now if you remember, x plus 1 was taken as 1 by t, so t will be equal to 1 by x plus 1. So minus log modulus of 1 by x plus 1 minus half you can write. You can keep it like that. Don't worry about resolving it. And t square minus t plus 1 will give you what? You can write 1 by x whole square minus 1 by x plus 1 and plus 1. So when you resolve this, the final result will come like this. You already know the numerator was from the denominator, that is in the question the denominator is x square plus x plus 1 that has come, and x plus 1 come held in the denominator. This is your final result. I hope you will be able to resolve this to find this one, the second part. So whatever we have done is presented to you. You can follow this. X plus 1 equals to 1 by 2 is a new thing which we learned here, and how to resolve this we have taken our previous experiences also. 1 by x square minus 1 under root x square plus 1. Now we have a quadratic equation. So would you like to take this under root x square plus 1 as some t, or rather take this x equals to 1 by t. So this x equals to 1 by t will be somewhat easier. When you differentiate both sides, 1 will be equal to negative 1 by t square dt by dx. So dx you are going to get dt divided by t square in negative sense, negative sign. Dx you got. Now we have to write x square minus 1 and x square plus 1 in terms of this x, which is 1 by t. So when you square it, you'll get 1 by t square. So this integration will become like this. In place of dx, let's write negative dt by t square. X square minus 1 will be 1 by t square minus 1, and under root x square plus 1, that is, you can just write 1 by t square plus 1. So what is the benefit? I'm writing this here. This 1 by t square minus 1 will be 1 minus t square by t square. 1 plus t square by t square for 1 by t square plus 1. 1 t can come out. Now the integration will become like this. Integration of negative dt by t square divided by 1 minus t square divided by t square actually, and 1 plus t square divided by t. So you have a t cube in the denominator, t square in the numerator. So 1 t will still remain, but when it goes up, it will form t dt. Now you will say that the same question, it was same, you just changed x into t. But if you remember, or if you witness, this t has come a new one. So we have introduced a t in the numerator, because if x would have been there, you could have taken x square equals to t, differentiated, and finally it's easily resolvable. Same thing we have adopted here. This t has come in the numerator. So please do not take t square equals to p or some value. Take under root 1 plus t square equals to some u. When you take this, 1 plus t square will be equal to u square. And then what will be 1 minus t square? First you have to differentiate this also. Let me differentiate it first. 2u du by dt on the right, and this will give you 2t. So you can just cancel this 2 and then t dt will be equal to u du. So we have got the numerator now. T dt, that you can write it as negative can be taken outside. T dt can be written as u du. So let's write this u du here in the numerator. In the denominator, under root 1 plus t square was already taken as u. So let's write u in place of under root 1 plus t square. So 1 minus t square also we are going to change in terms of u. So 1 plus t square is u square, t square is u square minus 1. And 1 minus t square is 1 minus u square minus 1, and that will give you 1 minus u square plus 1. So that will be 2 minus u square. So let's write 2 minus u square here. Now this u in the numerator and denominator get cancelled. So just have to resolve or use the formula of integration for du divided by 2 minus u square. 2 can be written as under root 2. So du divided by under root 2 whole square minus u square is the final result. So one more thing you could have done. This negative is already there. So you could have written it as u square minus under root 2 whole square. So this is up to you, that if you want to go along with du by under root 2 whole square minus u square, or u square minus under root 2 whole square with a negative sign fixed or removed. But we'll use the normal way. We'll keep the negative outside. We'll just talk about that. So du divided by under root 2 whole square minus u square we are going to employ. So it will be 1 by 2a. A is root 2 here. Log, and when you have a's, a square minus x square, a plus x will come in the numerator, a minus x will come in the denominator. A is u here, and a is root 2 here, and x is u here. But u was taken as under root 1 plus t square, if you remember. This is negative 2 root 2 log modulus of u can be written as under root 1 plus t square plus root 2 divided by 1 plus t square minus root 2 with a modulus sign plus a constant of integration. And one more thing is remaining, because t was taken as x, 1 by x. So t is 1 by x because x was taken as 1 by t. So what are you going to get? 1 plus t, in place of t write 1 by x square. So you'll get x square plus 1 by x square. That is x square plus 1 in the under root divided by x. So when you put it here, root x square plus x and plus a root 2 divided by under root x square plus 1 divided by x minus root 2. So you can take the LCM under root x square plus 1 plus root 2x in the numerator, and denominator under root x square plus 1 minus root 2 divided by x. You can cancel these two x's and keep it here. So the final result will be negative 1 by, final I am writing, negative 1 by 2 root 2 log modulus of under root x square plus 1 plus root 2x from here I am taking after resolving, and this is under root x square plus 1 minus root 2x plus a constant of integration. This is your final result. So this is how we are going to solve it. It was a kind of tricky question because first you have to take x equals to 1 by t, then 1 plus t square as u square, then only you are able to solve this. Now this seems to be a very easy question because there is one more question in the last. So you just notice how we solve this question. First you take t equals to x squared. So when you differentiate this, dt by dx will be equal to 2x. That means 2x dx will become dt. X dx will be dt by 2. Now we have got the numerator. We will change the denominator accordingly. X dx can be written as dt. Half I am taking outside as we have been doing in many questions earlier. X square is t, so t plus 4 here. Under root t plus 1. Now we need to get rid of this under root. That was the basic idea when we started this exercise. So this is a linear equation. We can go along with this. Under root t plus 1 equals to some p. So t plus 1 will become p square. That is t will be equal to p square minus 1. So let's differentiate this. 2p will be equal to 2p dp by dt will be equal to 1. So this dt can be written as 2p dp. So the integration has become, after all these replacements, 2p dp t plus 4. So you can just add a 4 to p square minus 1. Whole under root t plus 1 has taken p for replacement. And this t plus 4 is p square minus 1 plus 4. This will be p square plus 3. But root 3 square can be written because we want a square. Now this p and this p get cancelled. 2 gets cancelled from 2 outside. So dp divided by p square plus root 3 whole square, and 1 by a tan inverse x by a is the direct result which we have seen earlier also. A will be taken as root 3 and x as p. So 1 by a, 1 by root 3, tan inverse x by a, that is p by root 3. Now what was p? P was taken as under root t plus 1. So P was under root t plus 1. But what was T? T initially was taken as x square. So under root x square plus 1 can be placed in place of P. So we have final answer I as 1 by root 3 tan inverse under root x square plus 1 divided by root 3, because it is inside the root only. They both are roots. So how are we going to go about it? So this is very straightforward question. This we'll take in the next discussion. Till then, thank you so much. Have a good one.